go. Now, if you have to do reflective symmetry, you want the shape to match the shape on this side. And if we're reflecting over this line here, our reflection is going to come up here. And if it helps you, it depends. Some people are really good at these and some people find them tricky. Dot each corner. Okay, so if you dot each corner, each dot would have to be reflected on the line. So this dot is on the line, so it would stay on the line. This one is 2 away from the line, so it's going to be 2 away from the line up here. And this one is 2 away from the line here, so it's going to be here. And then you can effectively draw your lines and go from here. Reflecting over a horizontal or a vertical line is quite straightforward. When you do so, try and be as neat as possible. Use a ruler, shade in. Sorry, that's my dog. I think he's quietened down. And then we are going to now look at what you do over reflecting over a diagonal line. Now, again, if you're visual and you find this thing really easy, it won't cause you any problems. If you, like me, find visual things quite tricky, again, dot your corners if it makes it easier. Okay, so we'll deal with these ones first of all. And always think of it in terms of coming to the line in a straight line. So here, we would go diagonally across one square. So that dot is going to transport itself over here. Now for this one, we are going to go diagonally across 2 squares to the reflecting line. So we need to diagonally go across down here. So that's where that dot would go. So we've got another dot here. Now this one up here, let's have a look. And again, this is 2 going diagonally across 2 lines. So it's going to go diagonally across 2 lines here. And you now have your dots. Okay, so this dot here has been reflected here. This dot has been reflected here. And those 2 dots can be joined together with a line like this. This one has been reflected here, and this one has been reflected here, and they're joined together. And from there, you can recreate your shape quite effectively. And if we go across 1, down 1, and there you go. And you have reflected there. If you have used guidelines, just rub them out at the end, just so that they're not on the drawing, and you can make it nice and clear there. Okay, so that's reflecting across, that's a strategy for reflecting across a diagonal line. Now, rotational symmetry, about the center of order 2. So we want to create a shape that will land on itself 2 times as it goes round. So if you can imagine sticking a pin in here and then rotating this so that it lands on itself twice. So basically it would need to have its reflection at 180 degrees. So we're going to be shading up here. We can leave this L shape here blank. So this bit here stays blank. And you would shade in here. This one here is basically this one here. Okay. This one here will be, not there, sorry. This one here will end up over here. Okay. And then your three squares will come down here and be in this bit here. Okay. And if it helps you, you could get some tracing paper or some very thin paper that you can see through, and you can trace the shape and stick a pin in the center of that circle and swivel it round, and you'll see that how this will land on here, this will land on here, and this will land over here. Okay, let's come down and have a look at a couple of CSSE style questions with regard to rotation. So again, you can be tested on coordinates and rotation and reflection on the grids as well. So if we look here, we've got the coordinates of the point on arrow A are -2, 2. So they're talking about this point here. Okay, so the coordinates of that point there are -2, 2. If arrow A is reflected in the y-axis, now remember the x-axis goes across. Okay, so it goes, an x is across, an x goes across, and a y, the y-axis is your vertical axis, and I always think it's x goes across and y to the sky. Okay, so y goes up and down. Now this coordinates grid here, it has been split into 4 quadrants. You have your positive y here, you have your origin or 0 here, and then you have your negative y coordinates here, positive x coordinates go along here, negative your x coordinates go here. Now remember, with your coordinates, you always go along the corridor before you go up the stairs. So the x coordinate always comes first and the y coordinate comes second. If it helps you to remember, x comes before y in the alphabet as well, so you always do the x first. Now question A is saying if arrow A is reflected in the y-axis, so it's going to be reflected over this line here, okay, what will be the coordinates of the point on arrow A? So when it's a reflection, it's an equal distance from the line on both sides. So this is 2 squares away here. So it's going to be 2 squares away here. So the point on the arrow in the reflection would be here, and that would be 2, 2. Now, if we look at question B, if arrow A is rotated 90 degrees anti-clockwise about the origin, what will be the coordinates of the point on arrow A? Now, again, this depends very much on how visual you are. Some people are wonderfully visual and they can see it. Other people find it tricky. So I want you to imagine that point A, like a balloon, is tied onto the x-axis here. Okay, so that is tied there. It cannot move. Now, I find it easier to think of the x-axis itself rotating, not the shape. Okay, so the x-axis rotates, but point A will stay tied onto the axis at the same point. So we're going 90 degrees anti-clockwise. So that means we're going to rotate the x-axis round to here. Okay, so that is your 90-degree rotation. Point A is still tied on at the second point on this axis. So point A is still going to be tied on here. And if we were to come out, that's 2 squares off the axis to here, we would then have our new coordinate for point A. Now, I'm going to try and draw this freehand. It's not going to be brilliant, but I'll draw the shape so you can kind of see roughly how it goes. So if we come across here, the shape is now facing this direction. This is not the easiest shape to draw. Let's just come down to here. So this is now the orientation of that shape. Okay, you don't need to draw the shape, you can just focus on the coordinate. So the coordinate point now for our shape here for point A would be -2, -2. Okay, so it's -2 along the x-axis, -2 on the y. If the shape above is translated 5 squares to the right and 6 squares down, what will be the new coordinates of the point of arrow A? So you need to move 5 squares to the right. So if you come here, so if we go here, oh, this is a bad question I've written. Shape above is translated to the 5 squares to the right and 6 squares down. I think we have to talk about it being the original shape because we haven't been told it's the reflection. So if we take this shape and we go 5 squares to the right, so count 1, 2, 3, 4, 5, 5 squares to the right, 6 squares down, 1, 2, 3, 4, 5, 6. This will be where point A would land there. So the point on the arrow A would land here, and the new coordinates for point A would be 3 on the x-axis and -4 on the y. Now, in the CSSE, this will be much clearer as to which shape you are translating. But if it doesn't tell you, it's always the original shape, okay? Unless it's asked you to draw the shape in. You didn't need to draw a new shape in here, so it will always be the original shape that you're working with. Okay.